Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, and I'm here with another episode of Ask Dave. Today we're going to look at inverted V antennas, specifically a question that comes to us from John Martin, KB5GGO, Golf Ocean, Oscar, Golf Oscar. He says, I am attempting to put up an antenna for 75 meters. That's 3.9 megahertz. This is in the 80 meter band. The 80 meter band is so wide compared to its fundamental frequency that it covers from about 80 to about 75 actual meters. So 75 meters refers to the top end or the phone end of the 80 meter band. Specifically, he's looking for 3.9 megahertz. He's been watching videos, doing calculations, and still can't get better than greater than 9.9 to 1 on my meter, which is an MFJ213. Now, the MFJ213 is an SWR meter. It has the knob and everything, but there are no analog meters on it. It's digital only. Okay, and it's only good up to 60 megahertz, so it's not good for VHF or UHF. My 259B, I think it is handles all the way up through 2 meters, and it also has analog meters on it, so it's very nice. Okay, my situation. I have the center of the antenna about 45 feet up, hanging off my tower. Okay, so we have a great big metal post in the middle of the antenna. I have no good place to put the ends to the house at 45 degrees, so I'm trying various trees in my yard. All angles work out to more than 45 degrees by his eyeball. He hasn't measured it. At several attempts, I purchased a 1-to-1 balun and a 75-foot commercial coax. Balun is at the feed point. Antenna legs started at 60 feet, currently 58 feet. Nothing I have done improves SWR. So Sean is frustrated. Any advice greatly appreciated. My ham friends are mostly too young to have had vaccines, so I'm trying to do this on my own. Never had much luck making antennas. I have G5RV and butternut vertical, but neither is good on 75 meters. Love your channel. I think I'll subscribe and start watching your live shows live. Well, that's good. Please do subscribe. I'm trying to push the subscription up over 100K. Let's talk. There's a lot of things going on in this situation right here. First of all, let's look at the antennas he does have. Let's talk about 80 meters. 80 meters is a band that is very wide compared to the base frequency. The center frequency is 3.75 megahertz, and it goes down to 3.5 and up to 4. There is no way to build a dipole that will cover the entire range of the antenna. The only way you can do it, like my Step IR, Big IR antenna, which is currently out of service, covers it, but it actually lengthens and shortens the antenna in order to do that, and also changes a loading coil, 5 different steps on a loading coil. The best you can do with a dipole is maybe 100 hertz, okay, with an ordinary wire dipole. You can build what's called a cage dipole, which will broaden that coverage a little bit, but it still won't cover from 3.5 to 4. You can get maybe all of the general band of 80 or something like that. I have never had good luck with G5RVs. G5RVs are resonant antennas under very specific circumstances. Okay, and those very specific circumstances are hard to match. People think, oh, G5RV, I can easily match that. Well, with a very wide range tuner, maybe you can, but I've never had good luck with them. The butternut vertical the HF9V covers 25 kilohertz of the 80 meter band. You choose which 25 kilohertz, okay? Now, this is a band that's half a megahertz wide, or 500 kilohertz wide, and the butternut HF9V will cover only 25 kilohertz of that. That's also true of some of the other store-bought verticals, multiband verticals that purport to cover 80. They only cover a very narrow slice of it. That's because the antenna is highly tuned for a band that needs a very broadband antenna. Unfortunately, broadband antennas are hard to build, so we normally build resonant antennas. With a broadband antenna, such as a V or a horizontal V or a rhombic, which would be extremely big for 80 meters, you can cover the whole band, but otherwise, no. Now, the antenna that I have connected right now, we had a good day, so I went out and disconnected the coax from the MFJ 17754 and connected it to the My Antennas 8010, which covers, again, a small portion of the 80 meter band, in this case, at the bottom of the band. There is a modification you can make for it that will allow it to cover a higher, move up the 80 portion of the band up to 75. I haven't made that a modification yet. Okay, let's talk about inverted V's. Okay, first of all, what is the ideal height for an 80 meter dipole? An 80 meter dipole, the ideal height is half a wave, 40 meters, equals 120 feet. Okay, so the problem that you're having here, well, it'd be 132 feet if you actually take the metrics out. This would be for 75 meters, and this is for 80 meters. Okay, he has it 45 feet high. Okay, now the fact that he is so much below, get his name here, John, is so much below the optimum height means that the impedance at the feed point is going to drop. Okay, so that may be part of the problem, but that should not make the antenna resonant at any less than, won't change the resonance point or anything like that, but it will change the feed point impedance, which will change the SWR. So let's look at your classic inverted V. Has a central support and has the two halves of the dipole coming off like this, and this central angle right here, ideally, is 120 degrees. This has nothing to do with feet, okay? It's a coincidence that the length on 75 meters is 60 feet on the side, or 120 feet total, but 120 degrees. Certainly, if you want it to perform well, you want it to be at least 90 degrees. Okay, so this would be 45 on a side, when ideally it would be 60 degrees on a side. Okay, one way you can do this, assuming your yard is big enough, is to attach a rope to the end of it, and that allows you to pull that end out further as you go to further away trees, okay, to make the thing more. Now, if you come under 90 degrees, you're going to start having real problems with that antenna because it's starting to behave a bit like a feed line. The ultimate is this, right? And that is a feed line. If you go to 90 degrees, the thing sort of stops behaving as a feed line and behaves as an antenna. If you're less than this, if you have very steep, it's going to behave a little bit like a feed line. So you're going to get a worse and worse and worse SWR. Now, here, Rich, a couple things that you need to do. First of all, find out what frequency the antenna is resonant at. It's resonant at some frequency. Okay, so you can use your meter, which will do this, and your frequency, it sounds like the resonant frequency is outside of the ham band. Okay, then, so I want you to find out what the resonant frequency is, which may be outside the ham band. And then the next thing that we need is the R value at resonance, and then the Z value, or X. It'll probably say X. Ideally at resonance this should be 0, but sometimes, this is a fact of life, the way SWR actually is calculated, the lowest SWR may be at a point slightly different from where the antenna is resonant. That's because the R value, the closer you have these legs together, the lower the R. We want ideally an R of 50 ohms. But you're probably getting 30 or 20 ohms. Okay? If you do that, that goes into the SWR calculation, and no matter how much you prune the antenna, shorten it or lengthen it, it's not going to change that value. And because it's not going to change that value, it will not change the resonant frequency of the antenna. You'll have that, and you're going to have to take that out with a tuner or with a non-one-to-one balun, or you can use a stub tuner, or you could add loading, or there's a variety of things that you can do. Okay, so first, these legs need to be as far apart as you can get them, and one way to do that, if you've got a tree way over here, is just add some rope to the end of that and pull it over toward the faraway tree. Okay, you want that tie point up about 8 feet anyway. Lean a ladder up against the tree and tie it up so that, well, don't tie it so close to the thin part of the tree that it will sway. Find the base part of the tree that doesn't sway and tie it to that, but get it up above head height so people don't strangle themselves walking under it. Okay, and if you can't find X equals 0, you probably won't, because you've got the tower in there. The tower is, because you have it so close, here's what you do ideally. Climb your tower if it's safe. You should never climb a tower alone, right? At least have your wife there to either call 911 or the coroner, whatever. Climbing towers is dangerous. The older you get, the more dangerous it is. I don't go on my roof anymore. It used to be when we first moved here 18 years ago, I'd pop up on the roof and do anything with the antennas. I don't go on the roof anymore. But take a piece of redwood, at least 4 feet long, okay? Attach one end of it to the tower so that it goes out over the edge of the tower, okay? And then attach the antenna, the inverted V apex, to that point right there. Now you can bring the loop down to the tower to tie it off, and take the loop of coax down to the tower, take it to the ground. But that helps decouple the tower from your antenna. My research with modeling software has shown that if you've got two steel masts and a dipole in between, and the end of the dipole is less than 3 feet away from the mast becomes a radiating part of the antenna. So 3-4 feet will do it. Okay, so that's the first thing to do. Get those legs out as far as you can. Second, find out your R and X values, and to find that resonant point and get that resonant point back in the band. Now, if you still get a very high SWR, which you may, okay, but if you spread those legs out more, you should be able to get a manageable SWR. The thing to do is feed it with open wire line. 450 ohm ladder line will work just fine. That's actually window line. And bring it to a balun. It doesn't need to be anything very exotic. A 1-to-1, a 4-to-1, a 2-to-1, something like that. 2-to-1 probably. And then bring that coax into the station and try to tune it that way. I think you'll have a lot more luck with the tuner. Now remember, this inverted V is only going to be usable on a small segment of 80. That's just physics. The only way to make an antenna more broadband is to either find a way to physically shorten it and lengthen it, put a loading coil on the thing in the design that you can manipulate the taps on from in the house or something like that. It's just too big. The band is too wide to cover with just one antenna. That is too wide with relation to the center frequency. In fact, I did a video on that a while back about why you can't tune all of 80, but you can tune all of 40 with a dipole. Yes, we have 350 megahertz. No, yes, 300 kilohertz on 40. But it's based on 7.125 as the center frequency. It's a much smaller percent of the center frequency. And even more so when you go up, even at 15 meters, which is almost as wide as 80 meters, at 450 kilohertz, you can cover the whole thing with a regular dipole. But on 80 meters, you can't do that. Let's look at some of the other issues starting here. Okay, so yeah, that butternut, again, will only cover a small portion of 80, even with a tuner. It's just, the problem is that the butternut and other dipoles are high Q antennas. So if you look at, this is 3.5 kilohertz, so it's megahertz. My goodness. And this is 4.0 megahertz. Okay. The SWR on the thing is going to look like this. All right. It's going to be quite narrow, and this will be about your 2-to-1 bandwidth right here. Up in this region here, you're 10-to-1 or higher. Now, so you can tune it around just a little bit with the tuner, not very much. This will not touch 1-to-1 unless the X, the X equals 0 and the R equals 50. Then it will be 1-to-1. But your R is not going to be 50. Your R is going to be something quite a bit different from 50. Just because, 1, it's an inverted V, 2, it's not at its optimal height, 3, you don't have the legs pulled far enough apart, 4, you're right next to the tower, or was that number 2? Anyway, there you go. That's the best advice that I can give. 80 meters is a rough band, and that is why a lot of the people who are on 80 meters have their favorite nets within their antenna's bandwidth, have their favorite nets, and never move from there. It's very easy to build an 80-meter dipole for a specific frequency. It's very well, it's nigh unto impossible to build a reasonable size antenna for wider frequencies. Dipole antennas and all the variations on a dipole that we've talked about, including verticals, are resonant antennas, and they have a Q factor. Q here stands for quality, not question. Stands for quality factor. It's a unitless figure of merit for the antenna that talks about how sharp the tuning is. All antennas that come from a dipole are high Q. They'll cover a band like 40 meters. But if you try and use that same antenna to listen to the 49-meter shortwave band, you'll find it's a lousy antenna. In fact, you'll find it better to unscrew the antenna and just have the center part of the antenna in. You'll get a much better signal, because then that piece of the antenna is no longer tuned since it doesn't have the other half. Okay, so wideband antennas are not tuned antennas, so they're not variants of a dipole. So you can use a wave antenna like a horizontal V, going out like that in a diagonal, which is basically half of a rhombic. And you've got to have quite a few acres for an 80-meter rhombic. And then the problem that you run in there is how highly, highly, highly directional a rhombic or a V is. Okay? Another thing that you can do is to build an 80-meter full wavelength, in other words, 80 meters, 240 feet or whatever that is, 250, horizontal loop. Get it up as high as you can, and with a wide range tuner and feeding it with ladder line or window line, you can tune it over most everything. It's not so dipole-ish as other antennas. Okay, we've gone around in circles on that, and so the point I'm just trying to make here is that almost all antennas that ham radio operators use are resonant antennas, which means they will only work in a certain bandwidth, and on 80 meters that bandwidth is always quite narrow. So I hope that helps. Tried to give you some ideas of what to do with your 80-meter antenna. So John, thank you very much for your question, and thank you for saying you'll subscribe, and I hope that you do, and I hope you join us for our Thursday live streams. All right, so if you'd like to support this channel financially, you can certainly do so by going to dcasler.com/support. And also, please subscribe to this channel on YouTube, and and until we next meet, 73.